And we are live. Welcome everyone to the Somnia Codelabs. My name is Emmanuel and I am with the Developer Relations team here at Somnia. It's always a delight to anchor these sessions. And in this edition, we will be having a deep dive on using DIA on Somnia. And today we are featuring a special guest. It's my pleasure to introduce Hala. How are you doing, Hala?
Hello, thank you so much for having me here. I'm doing really well. Thank you. So excited to meet you all. GM.
Awesome. Thank you so much for being here, and it's a pleasure to have you. So, if it's not much of an ask, before we jump right into the session, can you share a brief introduction about yourself, what you do at DIA, and also just a brief intro into DIA before we kick off the session?
Sure. So I am a technical product manager at DIA, and I have been a blockchain developer for a couple of years. So I'm really happy to be doing this and coding with you guys. So what we're building cross-chain oracles, and currently we rolled out our new stack called Lumina. And Lumina is a decentralized Oracle network. That's what we've been currently focusing on and building. And we're going to share some resources for you guys to test it on Somnia at the end. So yeah, so excited to be here and nice to meet you all.
Thank you so much, Hala. And a few ground rules, everyone, just before we get right into it. Please note that this session is streaming on X and also on YouTube. And you can provide your questions by dropping comments on X and also comments on YouTube. And we'll be able to answer them at the end of the session. Please be civil and keep your questions to the topic being discussed and to other technical questions that you may have about Somnia or about DIA. So handing over to Hala right now to lead us through the rest of the session. Thank you.
Thank you. Okay, so we're going to be talking about, or I'm going to walk you through how to use DIA oracles on Somnia. So the agenda is to give an overview of DIA oracles and then talk about the different data feeds that we have on Somnia, and then talk about the project that we're going to be setting up, which is a lending protocol, a lending dApp, super simple. And then we're going to be setting up the project together, and we're going to be deploying it to Somnia. And then at the end, we'll take some Q&A. Yes. So let's talk about DIA. I'm going to probably start here from Somnia's docs. There is a brief introduction here to how the oracles work. But currently, we have those different, 1 minute, sorry, just sharing the wrong docs. Nexus, I just wanted to give a brief overview of the different Oracle stacks that we have. We have Nexus and Lumina, and that's the product that we rolled out that I spoke to you guys about earlier. And we're going to be testing the oracles on Nexus, but you'll also get a chance to test it on Lumina and give us your feedback on it. So Nexus is mainly a push oracle, and it's also, and it's not part of so Nexus is a push oracle, whereas like Lumina provides or supports different oracle types, push and pull. And it's also, they're both cater to different needs. And Lumina is more of like the evolved version of Nexus. So you can take a look here and explore it yourself to see the differences. So at a high level, the way that the current oracle works is that we have these oracle feeders that send price updates regularly to the Oracle contract that is deployed on the destination chain, which is Somnia in this case. And then what it does is that it calls, so at a certain interval, and it's governed by certain parameters. And according to these parameters or conditions, it keeps pushing those price updates to the Oracle contract by calling a set value function on that Oracle contract. And then at the end is at the other end is the consumer DApp, or the DApp that essentially reads those values from the Oracle contract by calling get value. So it's a very simple, which is what we're going to be going through today, and we're going to see that in the demo. And also just to explain the different terminologies that we use here. So the deviation is like, those are the parameters that govern the updates, essentially. Like, so whatever value that you receive at the end is controlled by these parameters. So we have a deviation, which is like a percentage that you set. In this example, for Somnia, the deviation for these, the deviation threshold for the Oracle is 0.5%. So whenever, so whenever the asset deviates from by 0.5%, then that triggers a push, that triggers an update on the Oracle contract. And then refresh frequency is like, it's a time interval in seconds that pushes these updates. So let's say every 30 seconds in this case, you will get, no, actually it's not every 30 seconds, every 2 seconds. Wait. Every 2 minutes, sorry. Yeah, every 2 minutes, it pushes a price update to the Oracle. And then a heartbeat is also like a forced update that is also, I believe, is in seconds or in minutes. Okay, so in every 24 hours. So in this case, every 24 hours, there's a forced update, regardless of the refresh frequency or the deviation threshold. So those are the different parameters that determine how frequently the prices get updated on the Oracle contract. So once you land here on this page, essentially, you'll see the configuration that the Oracle has on Somnia. But if you would like a different configuration, you can always reach out to the team and set your own Oracle with different parameters and different configurations. Yeah, so just to recap, this deviation threshold, it is measured relative to the price. If it deviates from if the price deviates from certain threshold, then that triggers an update. And then refresh frequency is just how frequently do you want the prices to get refreshed. And then the heartbeat is just a forced update, which is just like, let's say, a regular check every 24 hours, push a price update to the Oracle. And then here you can see the different asset feeds that we have on Somnia. So there is, so you can query for USDT, USDC, BTC, ARB, and SOL. Those are the different assets that we're hosting on the Oracle. And they also come with adapter addresses. So if you are using Chainlink, for example, but you want to be consuming DIA oracles on the backend, then you can do that through the adapter addresses. So we're very much Chainlink compatible, and we're also highly customizable. If you don't want these values and you want something with a different, like if you want a different setup, you can always reach out to us for that. And then the pricing methodology is also something that you can explore here and check the different pricing methodologies that we support. So for this particular oracle, we have the moving average with interquartile range filter. So you can read more about that here. Yeah, so this is how the current oracle works at a high level. And maybe we can get into the project setup, I believe. Okay, so what are we building today? We are building a simple lending protocol that is Aave inspired. It has two functionalities. It has supply and borrow, supply or deposit. And so there are two kinds of users. Let me show you here. Where can I share links? Can I don't know, maybe I can put them here. I'm not sure how this works, but I think I can, I don't know. Okay, so if you look at this introduction to Aave, we're gonna be building something similar. So there are two major functionalities that I want to focus on. We're not gonna be doing everything, just these two, supply and borrow. And if you read through this, you can see here that in this lending pool, so what happens is that you have this supplier, the user selects whatever cryptocurrency that they want to add or deposit into the pool. And then what they do, so if you don't know what Aave is a lending protocol. And it relies on this over collateralized lending type of setup. So you have a supplier and you have a borrower, and then the supplier provides liquidity to the pool, and then they can earn interest on their crypto. And then the borrowers, they get to borrow from the pool, but in an over collateralized fashion. So that means that like they have to supply in order to borrow. So when whatever they supply is more than what they borrow. And that is just one way of doing lending. And that's how Aave implements it. So what happens is that the user selects a supported cryptocurrency, let's say ETH, and supplies it to the Aave protocol. And then they get 8 tokens in return. And then they accumulate interest on these tokens. So it kind of represents their share of the pool. And then for borrowing, yes. Okay. So every borrower has to supply first, and then they can utilize the amount that they deposited as a collateral to borrow against. And that's how the contract setup is going to go. So we're going to have a supply function and a borrow function. And then in this case, there are going to be 2 users, a supplier and a borrower. Yeah. But then there are also parameters that govern the borrowing process. And there's a bunch of them. if you use Aave, you can use Aave on a testnet and then see the different parameters there. What we're going to be focusing on is the loan to value ratio. And that basically says, so if you have, so that's the maximum amount that can be borrowed relative to the collateral's value. So if you deposited some amount of ETH and your deposit is worth maybe $200, then you can only borrow, let's say, and the loan to value ratio is 70%, for example, then you can only borrow 70% of that collateral value. So that is the parameter that we're going to use for borrowing in our smart contract. So essentially, at a high level, you'll have this lending pool and you'll supply, let's say, ETH. You'll receive some AETH that represents your share of the pool. And then you get to borrow ETH using your collateral. Okay. So in order to set up the project, you'll need Node.js. You'll need Hardhat and some IDE. You can also use Remix IDE. Okay, let's get into it. Let me pull up the code that I have. Okay, we'll start with, where shall we start from? So open up your terminal and maybe create a new directory. Let's call it, okay, what should we call it? Let's call it Somnia dApp. And then cd into the dApp. And let's do npx hardhat init. And I'll click create a JavaScript project. Do you want to add a git ignore? Yes. Do you want to install? Yes. It's a little slow. Okay, nice. Okay, cool. Now I have Hardhat installed. Let me open my project using Cursor because I really like Cursor. Cursor is really cool. Okay, now we have a new project, a new Hardhat project. What we're gonna do, we're gonna create two contracts. One is a lending pool, which will consume DIA oracles. And then the other is just gonna be a mock ERC20. Let's start with, no, not here. Let's start with the mock ERC20 contract, okay? And it's just gonna be like a simple, it's one of those Open Zeppelin templates that you can find in their documentation. So I'll just take one of those and I'll use it here in my project. But of course, make sure you install Open Zeppelin, npm install, npm install at Open Zeppelin /contract, I think. Right? Yeah. What does it say? Oh. Okay, I'll just copy my package.json file. That will save me time. And then I will do npm install. Okay, nice. So what I have in my package.json is OpenZeppelin and .env, those two packages, and also hardhat. Okay, so now this is my mock ERC20. Let's create the lending pool. And I also have the lending pool ready. But let's start with this setup. And the contract is going to be called lending pool. Okay, what the hell is that? Okay, you can see here how you can see an example here of the of a sample contract of an integration example in the partners section. You'll find it partner section integrating Dia Oracles and Somnia. So use this. You can also use this as a template. And what I'm going to do is okay. So what you have to do is first declare an interface or create an interface of Idea Oracle v2, and then add this one function, which is get value. And then create your contract lending pool. Wait, create your contract lending pool, which will create an instance of Dia Oracle here. So you'll say Idea Oracle v2. Let's make it private. And then Dia Oracle. And then you'll pass the address to the constructor, and then wrap it or cast it into the Dia Oracle v2 interface. So that's how you're gonna use the Dia Oracle in your contract. But why do we need the Oracle here? We need the Oracle here for the borrow function. Because when you're borrowing, you need to find out what is your current collateral value. And then and then to get the latest price of, let's say, if you're supplying ETH and you want to borrow ETH, if you supplied ETH, then you want to find out what is the current price. And so to get the current price, you need to invoke Dia Oracles, right, for that. And it is one of the, do we have ETH? No. So then maybe you can use BTC. Let's do BTC. Okay, and then let me copy whatever I have here. Okay, and this is how the constructor is going to look like. So now we have Dia Oracle declared here, and the address of that Oracle is going to be passed through the constructor. And then let's say the asset that we're going to use as a collateral is BTC. And then we're going to have one mock ERC20 token, which will act as the share representation or your collateral. And also at the same time, it will act as a token that you're borrowing, and also as the your collateral essentially. So I'm gonna call it as a mock ERC20 token. Or maybe just a token. Let's do just a token. And then the LTV, which is the loan to value ratio, I'm gonna set it to 70, which is again, it basically determines what is the maximum value that you can borrow. And then there's gonna be a mapping that maps your address to your collateral or deposited amount. I'll call it deposit amount. And then another address for mapping how much your address to how much you've borrowed. So it's sort of like a balance. It just tracks your doesn't track your balance, but just tracks how much you've borrowed and how much you've deposited. And then there are two events: amount deposited and amount borrowed. And then, yeah, so the constructor will take, let's say, one address per token. Yeah, let's do token equals mock. Then let's copy the supply function here. And also let me copy the borrow function to save time. But I want to fix a few things. Instead of having two contracts, I think I just want to have one. And this will act as the BTC and the ABTC. Let's just think about it this way for now. This is the BTC, and this is, let's say, the ABTC being transferred back to you. Okay, so how does supply work? You give an amount, and then it checks if the amount is greater than 0, and then it transfers the BTC from you to the contract, to the pool, with the amount that you've specified. And then it will transfer back to you an ABTC that will represent your share in the pool. And then it will increment the deposited amounts, which is essentially this mapping: deposited amount message.sender plus equals the amount. So it just increments your deposited amount by amount. And then it emits an event that's called amount deposited. Then we have the borrow function. The borrow function also takes an amount, and then it checks if the amount is non-zero. And then it will declare a variable called collateral amount, and that will equal to the amount that you've deposited, or so that will be your collateral amount essentially. We're accessing that through message.sender. And then we're requiring that you would have some collateral, and we do that by checking if it's non-zero. And then here comes the part where you call dia oracles, call dia oracle, right? Yeah, to get the latest price of BTC. Thank you, AI. And because we know the contract address, so I don't really, I just also thought about this. We don't really need to pass the address here. We can just assign it immediately. So we can do, I think we can do this. ID oracle, and then I can pass Or maybe let's just pass it for now. Let's not confuse the people. Okay, so yeah. So then this is the part where you call dia oracle. You say dia oracle dot get value, and then you pass the asset symbol, which I've set as a private string. It can also be a constant, actually. Give me a constant. Let's say as a constant for now. You'll pass it to get value, and then it will fetch two things. It will fetch the, where is the code? Here. It will fetch the latest price and the timestamp of the latest price. So that is like once the price has been pushed to the oracle, it will also submit the timestamp of that push. So I don't want to use that value. I just want to use the latest price. So I'll call dia oracle.getValue. And then let's get quickly into the calculation here. You have collateral value. The way that you calculate it, you take the latest price, you multiply it by, and the number of decimal places is 8. That's what you get from the oracle. And so then we just kind of scale it down to like 18. And then you have allowed borrow amount, which is how much can you borrow given the value of your collateral. That will be the collateral value times the loan to value ratio or percentage. And that's what we're doing here. And then we're requiring that the amount that you're borrowing plus your borrowed amounts are less than or equal to the allowed borrow amount. And then we transfer BTC to you here. Again, just think of this as a BTC. And then that will increase the borrowed amount that you have. And then we'll emit an event called amount borrowed. Okay, oh my goodness. Let's do npx hard hat compile. And let's get this deployed to Somnia. Nice, we're getting errors. Do you mean token or token? Are you serious? Okay. Okay. Because this was changed apparently. Okay. And then what is the error here? Not found. No. That's strange. Let's see. Okay, compile successfully. Now I want to deploy this to, so you'll write the deployment scripts here inside this folder, and I have the scripts ready. So I'll just, let's start with mock ERC20. Oh my goodness, mock ERC20. I'm afraid we're running out of time, so I'll keep it short. If not, I will push this, I'll push this code to a GitHub repo so that you can test it yourself. But let's say mock BTC, and then we do BTC. No need for ID. And I was doing something else here, but let's delete this. And let's make it one contract because we don't want bugs today. No. Contract. Is this written correctly? I don't think so. Okay, I need to delete this. Wait. Contract dot mock okay. And then What is going on here? Why is this in red? Wait, you passed the string, right? The name, and you passed the symbol. Okay. Wait, you're passing. Why is this not working? Mock ERC20. Oh, why is this in Solidity? Oh my god, that's so JS. Please, what the heck? M.contract. Okay, return contract. And then another script for lending. Okay, those are a bunch of scripts that I've deployed. Modules. Let's create another deployment script, lending pool.js. I'll keep it fast. Okay. Okay. Then let me use the other. Let's cd into dash examples. Okay, I have something here. Okay. I just realized. Anyway, so then when you're deploying, you need to pass, for the lending pool, you need to pass the Oracle contract. You need to pass the tokens. You need to pass the token addresses. So because I've changed some things a bit, let me copy this and paste it here. Okay. And mock ERC20 stays the same. Lending. I'm gonna take you'll take the Oracle contract address from here, pass it to the lending pool constructor, and pass also the mock ERC20 token deployment. How much time do we have left, Emmanuel?
I think it's fine. We can keep going and then have this deployed and have it working.
Okay, sounds good. Okay, so for the lending pool, I'm going to be passing the Oracle that we have here that you can find in the Somnia documentation. And then I'm going to pass the deployed token. But I have not deployed the token yet. So let's do that. Okay, copy, paste it here. Sorry for that. Wait, why is it? No, it's here. Let's put it here. Okay, and then let's compile and run this. We're gonna use this script to deploy the mock ERC20.js file. Okay. Yeah. npx hard hat compile. You're not inside a hard hat project. Be serious. Nexus. EVM. Okay, that's another project. Okay. Yeah, ending that. Okay, this is a lot easier for me. And then, oh no. npx hard hat compile. One Solidity file. Excuse me. Maybe because this hasn't changed. Okay, makes sense. And then I'm gonna do. Oh no, why am I deploying it to Somnia? Oh yeah, sorry, I kind of missed this part. So in the Somnia documentation, they show you exactly how to deploy, how to change or how to set your configurations in Hard Hat. So go to that section. It's deploy and verify a smart contract on Somnia using Hard Hat. And it shows you all of the steps. I just followed the same steps. And what do you do? Yes, you add networks. You add Somnia to the networks. And then if you want to verify, you should also do all of those things. Like you should set the Etherscan API key, and then set sourceify to false, and then set a custom chains inside Etherscan because I made that mistake. And then obviously don't forget to create your own env file and put your private key there. Okay. So I did all of this, and this is my this is my hard hat config. Now I am ready to deploy it to Somnia. Oh, okay. So npx hard hat ignition, I think that's how you spell it, ignition deploy, and then mock ERC20, and let's deploy it to Somnia. Oh my goodness, confirm, yes. Failed. Consider modifying you want to remove inconsistencies with deployed features, whatever that means. I think I already have one. Maybe I should clear the cache. Yeah, maybe I should clear deployments. Let's see. CD2 ignition -rf deployments. And then maybe also try to clear the cache. And the artifacts, but I don't know if it matters. But let's do this. Okay, clear. And then let's do npx hard hat compile. npx hard hat compile, right? Okay, nice. And then we run the script. Yeah. Please work. Hey, let's go. Okay, we got this. Let me see. Let me check the Somnia Explorer. Where is it? How's everyone doing though? Oh my goodness. Wait. Where was the Explorer? This is the Explorer. Is it this one? I hope it is. Yay. Now I'm going to copy this contract and paste it here. Yay, we have our mock BTC deployed on Somnia. Let's go. Now, the second part is deploying the lending pool on Somnia. NPX hard hat. Lending pool, please don't disappoint. And let's change this to lending pool. Lending pool. Oh, wait. In lending pool, I need to pass the token contract address. So let me copy this and paste it here. And we got contract lending. Okay, so we're passing two things to the lending pool. We are passing the contract address for DIA oracles on Somnia, this one, and we are passing a mock ERC20 token that we can do whatever we want with it. Like, it's just a mock ERC20 token. And now we're going to deploy. Let's hope that it works. Yes. It's deploying. Why is it redeployed though? Okay. Now let's go to the Explorer. Let's paste. Lending pool deployed, but we cannot interact with it. So we need to verify. And Somnia got you covered in the docs. So we're gonna do that. Where's the command? You can use the command here. Wait. Yeah. Okay. Yeah. This is how the command looks like. First, I'm gonna verify. Sorry, I'm gonna verify the mock contract, and I'm gonna pass the deployed contract address for the mock contract, which was, what was the address? It was this one. And what were there any? Yes, there were. Which one was it? Yes, here. Okay. Yeah, we passed these two things to the constructor, so you also need to pass it to the verify function. Paste, and then also paste this. I hope it verifies it. Hey, it's getting verified. Let's go. And I'm gonna refresh this. Okay, so here's the contract, and we can see all of the read and write methods here. Okay, let's do the same thing for the lending pool. Lending pool, and pass the contract address and the constructor arguments. Contract address was lending pool. It's this one, right? Yeah, what is this one? And the constructor arguments were, what were they? Yeah, it was this. It was the Oracle address and the token address. Okay, done. Let's verify. Yay, verified. Let's go. Refresh. Yay, we have our methods here. Okay. Now we get to interact with the functions. But it's not here. It's on the other browser. So let me share the other one real quick. Okay, nice. Nice. Let me show you how we interact with it. Okay, I could bring this over here. I hope you can see it. Yeah, I think you can. Okay. Okay. And another one for, let me close this. No, what the hell? I hope I still have the contract on this one. Oops, sorry. Okay. Yeah. Nice. Now, what are we gonna do? We're gonna read write. We want to supply tokens again. You need to supply in order to borrow. So to supply, you need to approve. You need to approve first for the lending pool to spend your tokens. And so I'm just going to invoke the spend function, and just really quickly. Okay. I'm going to give it the address of the lending pool. Copy spender approve, and is my, okay, am I connected? Am I hope I am. Yeah, I am. Wait, no, but I used another true. Yeah, let's do this one. Disconnect, and then connect again. Connect. I think I'm the owner. I think I am. Balance of me. Yeah, nice. Okay. I'm gonna give it an allowance of 1,000. Let's consider it a BTC. And that's the allowance in way. And I'm gonna click write. And I hope it assigns it some allowance. And confirming, it's gonna cost me 0.0002 STT. Okay, now we check the allowance. I'm gonna put my address and the pool's address. Okay, cool. So now we're gonna supply, and let's say I'm gonna supply 500. I gave it an allowance of 1,000, so I'll give it a 500. I hope this works. Right. Confirm. Please work. Reverted. Oh no. Okay. Why did it revert though? What if I give it the full supply? But it has an allowance. Let's try. Okay, execution reverted. But I think even though it does have an allowance, That's crazy. That is crazy. Copy. Spender. Okay, this is right. This is right. And this is my address. Yes, read. We've approved the amount, yet it is failing. What did we do here? It works and then suddenly it doesn't. Token transfer from. But anyway, I think we're already over time. But yeah. I'm not sure why it's reverting. Is it because of, I don't know, let's try 500. No, it's not working. Okay. I think this will take time to debug. I'm not sure. What do you think, Emmanuel?
Yes,
Yeah.
I do agree on that. I think it's always something that we can revert to in the comments. Like you did mention, you share the GitHub repo
Yeah.
so that developers can check it out themselves.
Okay.
And then we'll add an extended guide to explain all of the concepts.
Okay, sounds good. Let's do that.
Awesome. Awesome. And also, we can also make a another recorded session that breaks down the components that's just going to run maybe for a few minutes to like explain to developers what it's meant to look like at the end.
Okay, sounds good.
Awesome, awesome. This has been a really delightful session. Thank you so much, Paula.
Thank you so much.
I'm going to open up cameras again, interact with the audience. So just a few questions because we are like way out of time. So I don't think we will be able to take any questions from the audience at this point in time. But I do have just one. So what other industry use cases, right? Aside DeFi, can developers leverage DR oracles for?
Um, one use case that I can think of is randomness, which is also something so that you can use in your gaming DApp. And we're currently developing a product that we might launch soon, which is Dia VRF, and that is going to be powered by our decentralized Oracle network. So you can leverage that. It will generate random numbers in hopefully like in sub-seconds. And yeah, so you can use the oracles for randomness, and you can also use it, mostly people use it for their DeFi dApps. So yeah, that's one use case for, yes.
Awesome. So just before we round up, two things. First, can you share with us how developers can get access to more support from the DR team?
Yes.
And then once you have shared that, yeah, can you go ahead, please?
Yeah, sure.
Where can they?
You can reach out to us on Discord. We're very active there. You can also reach out to us on Telegram. We're available there. Or maybe even DM us on Twitter/X. We are everywhere. So we would love to hear from you, everyone who's building on Somnia, and we'd love to offer help. Unfortunately, this did not work, but hopefully we can set something up together. And then if you're also interested in having your own custom Oracle, feel free to reach out to us.
Awesome, awesome. And then just to add a layer to what you said with your permission, it did work,
Yeah.
right? So And then we are going to come back with a follow-on video that will explain to developers just the last components after we've deployed the
Correct.
contracts, how do they to interact with each other. So that's fine. Usually, I close out the session by asking our guests to leave us with some parting words of advice for the community. So, what would be your words for developers of two categories: those who are just getting to learn about oracles and those who already know about oracles? Thank you.
Sure. Advice to people getting into oracles. I think the Oracle space, like I remember starting out and then just like not knowing what's going on under the hood. It can be a little complicated. So if you're starting out, look for a supportive team, reach out to the teams, discuss ideas with them, read through their documentation, see what works for you and for your use case. And yeah, just like explore every Oracle solution that's out there, and obviously come to us. And yeah, so in terms of development itself, it's really not that complicated to integrate an Oracle into your solution, to be honest. I think it's more about what are the different parameters that govern the Oracle itself. That's what might be a little tricky. And then also your preference in terms of like maybe latency and the different kind of assets that it can support. So from the development side, it's easy, straightforward. There's nothing to worry about. Yeah, just focus more on the things that make up the Oracle itself, like the configuration, and see what works for you there.
Awesome, awesome. And there is no better place to close it out on support and documentation. So please kindly go to the Somnia docs, kindly go to the Gear docs to find all of the guidance that you need to start building out oracles. And then again, the team is very responsive across the Discord, Telegram, and also for us, you can always reach out to me on Discord.
Yeah.
It's been a delight.
And just one last thing.
Today.
We are, so I spoke about Lumina earlier, and I just want to let you guys know that you can start testing Lumina on Somnia and experience the full Oracle solution and its power here. So if you go to the section fetch price data contract address, you'll see the contract. You can use a push or pull Oracle depending on your use case, and you can start using that here. We've made a special deployment for this session, so we would love to get your feedback on this too.
Awesome, awesome. Kindly go to the DR docs and start testing that out immediately. It's been a delight doing this with you guys again this week. Remember, the community, it's Somnia, and Somnia is the community. Stay with Somnia, everyone.